Now we'll proceed to the next type, that is type 2. All right. Type number 2 is the phi of x, that is the RHS of your given differential equation, will be either sine or a cosine function. Okay, so that means phi of x is either sine of ax, or it can also be cos of ax. All right, so we are going to get right the question based on this category, right? So what we are going to do, we'll see now. So what is the yp? So 2 pi yp, I have the standard equation, that is the phi of x divided by f of d. Now I have phi of x as two category. I'll write both of them. Okay, so let me go to a new line. So in this case also, finding the yc still remains same. Yc, there is no difference. Okay, you find the auxiliary equation, find the roots, compare the roots with the table which we have already written, okay, and find the yc. After that, if the right hand side of the equation falls under this category, then you find yp using this technique. Okay, that's the difference. Okay, so if at all phi of x is sine ax, right, this implies, so yp should be equal to either you have sine of ax by f of d, or I can also have the yp is equal to, it can be cos. Okay, this is cos ax divided by f of t. Right. In this case, again, very much similar to the previous case. Previously, we had replaced d by a. Now, the solution comes with this category. What I'm going to do, I'm going to write a d square by minus a square. You take a square, put a minus, that you replace for d square, not to d. So, obvious question, what if I don't have a d square in my equation? You have to bring it somehow. How to bring it, we'll see later. Okay, so similarly on the other side also, if it is a cos ax, still you do the same thing, replace the d square by minus of a square. So where is a? A will be present inside your bracket of a sine or cos. If it is simple sine x, a is equal to 1. If it is simple cos x, a is equal to 1. Otherwise you can see the a over there, something like sine of pi x, so a is pi, like that. Okay, so once you do this, what happens? The denominator is f of a minus a square. Correct? So let me write that. This is equal to, I get sine of ax by f of minus a square, because every d square I am going to replace by minus a square. All right? Replacing d square by minus a square. Right? Or I can also have the sine of not sine, sorry, my mistake, it should be cos, because the right hand side we have cosine function. So let me replace this sine by cos. Okay, so this is equal to cos of ax whole divided by cos of ax divided by, this is f of minus a square. Now I have a condition that, see the denominator, when I substitute minus a square, denominator should not be equal to 0. Correct? So I'll just write, so dr stands for denominator, should not be equal to 0. So I'll write my next condition, that is, so what if denominator is equal to 0? Like the previous problem, right, previous case, I'm supposed to do one thing. If denominator is equal to 0, the same yp becomes equal to, what you did, if you recall, you simply multiply the term by x, keep the numerator as it is, sine of ax, but denominator you differentiate. Instead of writing f of a square, you write f dash of a square. Or The other answer should be x into, since it is a cosine function, you write cos of ax divided by, previously denominator was 0, so you take differentiate and then substitute. Sorry, this is minus a square. Okay, f dash of minus a square. So everywhere whenever you get a d, you have to write, replace the d square by minus a square. What if once again I have the same condition coming up, that denominator should not be equal to 0? So if at all while solving this you get the denominator of the previous step is 0, then once again you update. Yp should be, already there is a x, always the rule is multiply by ax, differentiated denominator. So already there is a x, if you multiply by one more x, it becomes x square sine ax by f dash is there, now I write f double dash. Okay, f double dash of minus a square, or right, x square, this is cos of ax by, this is f double dash of minus a square, right? The condition proceeds, right? Still I need to check whether the denominator is 0 or not. If it is 0, proceed further, make it x cube sine ax by f triple dash of a minus a square, or x cube into cos ax by f triple dash of minus a square, and so on. You proceed further until you get a finite answer in the denominator. Denominator cannot be equal to 0. That's the ultimate thing which we need to remember. Alright, so now we'll directly go to the problem based on this second category. Okay, so type 2 problem. Problem number 1. This is say y double dash minus 4 into y dash plus 13 into y is equal to, this is cos 2x. So I know that y double dash stands for d square y by dx square minus 4 times dy by dx plus 13 times y is equal to cos 2x. Okay, once I have this, I know that I have two steps to follow. First step is common, that is to find the yc. That's my first step. So what I do, I replace d by dx in my equation by capital D, and I also make the phi of x, that is the RHS, is equal to 0. So after doing that, I'm going to get, this is d square minus 4 into d plus 13. Remember that I have to take a y outside. I can skip one step and I can save some time. This is equal to 0. So this part is my f of d. Okay, so this means I have to equate this to equal to 0, but since it is a operator, I cannot do that. I have to write an auxiliary equation. A is given by, for this case, it is replace d by m, so m square minus 4m plus 13 equal to 0. Okay, so let me think of factorizing it. I think factorization is not possible because I have to get a 13 as a product. Okay, so I will go with the equation method. Okay, so m is equal to, this is minus b, so this is minus of, b is minus 4, minus of minus 4 plus or minus under root b square is minus 4 square, b square minus 4 into a into c is 13, all right, whole divided by this is 2a, so 2 into 1. So I have two roots coming up, both the roots can be calculated using this. So this means it is 4 plus or minus, see there is a 4 square is 16, 16 minus 52. So from 52, if you subtract 16, I think it's a 36. So plus or minus under root, this is minus 36, whole divided by, we have 2. So this is equal to, I can write the roots as now 4 plus or minus under root of -1 is I into root 36. 36 is 6 divided by 2. So I can cancel that with the denominator. 2 cancel with 4 as 2 plus or minus 6 I can cancel with 3. So 2 plus or minus 3i are the two roots. So I understand that this root is actually a complex conjugate. So complex conjugate roots falls under the third category of our table, right? And when I refer the table, I understand that. Therefore, the YC can be written as e to the power, the real part. Real part in this problem is 2, correct? So this is e to the power. I have to write, say, 2x into a constant C1 into cos of 3x, that's the imaginary part, plus a constant C2 into sine of 3x. So hold on to this equation as equation number 1. So we got till here. This is the first part which is common for everything, YC. Okay, next part is to find YP, the particular integral solution of this part. So we know that I have to bring back the phi of x and divide that with the f of d given in this problem, whatever we obtain. So I'll just go back to see what was my f of d. So if you remember, f of d we got here, that is equal to d square minus 4d plus 13. So I'm supposed to use the same thing now to substitute in this problem. Okay, so let's do that. This implies, so yp has to be calculated as the phi of x given in the equation divided by the f of d, right? In this case, I understand that therefore yp is equal to f of x. F of x is a cosine function, cos of 2x divided by f of d. If you look at the f of d, that is d square minus 4 into d plus 13. So we have this. So as soon as I see the cos x or sin x, cos ax, sin ax in my equation, see the difference, it is not cos hyperbolic, it is not sin hyperbolic. Cos hyperbolic as well as the sin hyperbolic, they belong to the previous category, that's type 1. But simple cos and simple sin functions belong to the second category. So in the second category, I know that my substitution should be d square should be replaced by minus a squared. So this a I'm going to get from here inside the cosine bracket or the sine bracket. Right, so now I know that inside this bracket I have a 2, but I should replace it as minus of 2 square. 2 square is 4. It's always minus a square. Okay, that's my substitution. So this means I can replace only d square. I cannot touch the d. That's the problem. Okay, with this. So this means it is equal to cos 2x, numerator as it is, in the denominator wherever you see d square, replace the complete d square by minus 4. So indicates that I have to remove this d square and I should write what? I should write a minus 4 over here. Okay, so let me do that now. So this is equal to d square should be replaced as minus 4 minus 4d. Remember, you cannot touch d, you have to replace only d squares, plus 13. So this means it's going to reduce now to cos 2x whole divided by, there is a 13 minus 4. 13 minus 4 is 9. Okay, 9 minus 4d. So this is not the answer. Okay, if you observe, I still have a d uh, in my function. So I cannot have a d over there, because I need only the function in terms of x. So what you do, right, how to remove this d in the denominator, right? We perform the what we try to we can do here is that you can try to multiply and divide by, right, something like a conjugate. That's like this. So I'll write as it is first. So this is cos, okay, this is cos 2x divided by, this is 9 minus 4d multiply with 9 plus 4d divided by 9 plus 4d. Okay, so just we can do this because anyway numerator denominator they actually cancel each other and I'm not doing anything. But this helps me in eliminating the d from the denominator, and I am going to replace the d by d square because of this. Okay, let's see how. So this is equal to, so numerator what happens, you multiply term by term. So because this is 9 plus 4d in the bracket, 9 plus 4d in the bracket. So because of that, this cos 2x gets multiplied to both terms as I am writing now. So first term is 9 times cos 2x. This is my first term. Similarly, plus this 4d into cos 2x whole divided by, I'll tell you how to simplify this now. Denominator. So if you see the denominator, this is pretty straightforward. Why we multiply by 9 minus 4d into 9 plus 4d? Because this is like a minus b into a plus b. So I know something about this. If you multiply a minus b into a plus b, the answer is equal to simply a square minus b square. Correct? So because of that, now I can write a square, a is 9, 9 square is 81 minus b square is 4d. So 4d square is 4 square is 16, d is d square. So I got a d square in the denominator. But there is a d in the numerator. What to do that, right? So if you remember, there was a substitution we made already. What was a d? D is nothing but d by dx. Right? So in the next step, I'm going to replace this using this technique. So this means it is equal to 9 into cos 2x first term plus 4 times, you see this is d by dx actually, d by dx of cos 2x, because there was a d in the numerator. I cannot keep it. I have to do something with that. I am going to do this. This is 81 minus 16 sorry d square. So now there can be a question saying that why don't I substitute denominator d as d by dx, right? This is obvious because since it is case 2, this d square can be substituted as minus a square in a later stage, definitely. So no problem with that. Okay, I can keep it. So that's why I'm not touching the denominators d square. Only numerator I apply d as, I replace it back. D, capital D, I'll replace it with d by dx. Alright, so let's proceed further. So this is equal to 9 cos 2x plus 4 into derivative of cos 2x. So if you remember, cos derivative is actually minus sign. Okay, so this is 4 into minus sign of 2x into 2, because 2x derivative is 2, right? Whole divided by, this is 81 minus 16 d square. So let's simplify the numerator first, then we'll come to the denominator. Okay, so this means this is 9 into cos 2x. So there is a minus, 4 into 2 is 8, minus 8. This is sine 2x whole divided by, now 81 minus 16 d square. Now I'll go for a simplification of the denominator, saying that replace the d square by minus a square. So this will not change. Once you start with the minus 2, a as 2, so already we have substituted d square as minus 4. You keep repeating the same thing always. Okay, so this means it is 9 into cos 2x minus 8 into sine 2x whole divided by, this is 81 minus 16 into d square is equal to minus 4. Okay, 16 into 4. 64. So that's a minus into minus is plus. So 81 plus 64 is 145. Okay, so I can directly write the answer as this is equal to 1 over 145 into this is 9 cos of 2x minus 8 sine of 2x. Okay, so this is the answer YP. So we got a YP. So final answer, the solution of this given problem is Y is equal to YC plus YP. So YC already we got the answer, that is e to the 2x into constant into cos of 3x plus another constant C2 sine 2x. This is the first part. Plus now the YP we just got as 1 over 145 into this is 9 times cos 2x minus 8 sine 2x. Okay, now let's recall what we did. So I'll go to the top. So this is a question, y double dash minus 4y dash plus 13y is equal to cos 2x. We converted that into the d by dx form and equated the RHS to be equal to 0 to get this part. Okay, after that I write the auxiliary equation, find the roots. So I find the root roots are complex conjugates 2 plus or minus 3i. Okay, so this roots, right, referring to the table, I understand that this is third category. I can write the YC in the following format. Okay, YC is equal to e to the 2x C1 cos 3x plus C2 sine 3x. Standard way of writing this. Till YC, there should not be any problem. Okay, now we come to the YP part. YP is the standard equation is phi of x by f of d. Phi of x is the right hand side, which we neglected earlier. Now we are going to put it back. F of d we obtained during the problem. Right. So in this case, I see that f phi of x is cos 2x and the f of d is d square minus 4d plus 30. As soon as I see the cos 2x in the numerator, I should understand that this particular problem is type 2. Okay, so I have to make a substitution that d square is equal to minus of a square. So a in this case is inside the cos bracket, whatever you see the number, that is the a. I should take the square of that, 2 square, so 4 minus 4. So you see that we are going to replace the d square as minus 4. So that's what I have marked here. So after that, so I write cos 2x by minus 4 minus 4d plus 13, which comes to be cos 2x by 9 minus 4d. So when you have 9 minus 4d with you, it's clear that, right, I have to eliminate the d from the denominator by having a square. Only when you have a square you can substitute, because this is type 2. Type 2 rule itself is suggesting that you can replace only d square, you cannot touch the d's. So in order to cancel that, whatever is in the denominator, I change the sign and I multiply. So 9 minus 4d I had, I multiply and divide by 9 plus 4d as shown. So out of which the denominator is a square minus b square. That format I can bring. So a is 9, so 9 square is 81. B is equal to 4d, so square is minus 16d square. At the same time, numerator you multiply cos 2x and 9 plus 4d. When you multiply, you get 9 cos 2x 4d times cos 2x. So here what I do, I use the property that the capital D is originally a d by dx. So this d I am going to replace as d by dx. Everything else remains same. Okay, so d by dx means it is an operator. Whatever is inside the bracket, you need to differentiate. So remaining others are as it is, right? In the next step, I can see that cos 2x differentiation is minus sine 2x into 2, right? I eliminated the dy dx and I substitute for that value. Okay, now after that, my next step is I'm going to simplify further. So simplify, 4 into 2 is 8 minus 8. So I have this term, denominator is still same. Right. Once you simplify the numerator, you can see that I can touch the denominator now by making the same substitution because there is only d square. There is no other term containing d in my equation. So when you have that, d square is minus 4. So there was a 16d square. So look at this, 16d square is replaced by 16 into minus 4. So 81 plus 64 is 145. I'll take the 145 outside as 1 by 145, remaining terms as it is. So that is a y. Okay. Once you get a yp, substitute in yc plus yp format to get the final answer y, and this is the final answer that we got. All right. The next question is this. Question number 2 is y double dash plus 9y is equal to cos 2x into cos x. Okay, now we start solving the problem normally. That I replace y double dash is nothing but d square y by dx square plus 9 times y is equal to cos of 2x into cos x. So anyway, for the first step is to find the yc. To find yc, I neglect the RHS and I write this. So to find yc, I'll put d by dx, replace it by capital D, and I make the RHS should be equal to 0. So when you do that, the d square y by dx square is capital D square plus 9, okay, into y. It's actually d square into y plus 9y. I take the y outside. We'll save some time, okay, and the right hand side should be equal to 0. So in this case, I understand that this is the f of d. So what's my next step? Definitely I have to write the auxiliary equation. So auxiliary equation is replace d by m. So this is m square plus 9 should be equal to 0. So if this is the case, I know that the roots are m square is equal to minus 9. That implies m is equal to plus or minus root of minus 9. So that is equal to plus or minus root of minus is I, root 9 is 3. So this is 3i. So it means it's conjugate pairs. Roots are complex conjugate pair. So as soon as I see that the root is complex conjugate and it's a pair, I can write the yc as, this is case number 3 of our table of yc. So it is e to the power real part. There is no real part here. You can see that this is 0 plus or minus. So since it is 0, it's e to the power 0, which is 1. I don't have to write that part. Simply write c1 into cos 3x plus c2 into sine 3x. Equation number 1. Okay, now let's go to the next part. The next part is actually to find yp. And from the basics, we already know that yp can be always calculated as the replacement of phi of x and dividing it by f of t. This is the basic equation irrespective of which type of problem we are solving. Okay, so this implies, therefore, yp is equal to, now I'll substitute it back. Okay, I'll substitute the function back, that is cos of 2x into cos of x whole divided by the f of d. If you observe the previous step, that is yc, I have d square plus 9. This is the f of d. Now I know that I can actually make a substitution like d square as minus a square. But what is the a? I don't know, because there are two cosine functions. Cos a into, there is a cos a and cos b. Right. I cannot take this has no straightforward solution until and unless I use some trigonometric identity and bring it back into some other format. Okay, so let's go with that. So if you have, right, a format like cos c into cos d, I'll write the equation, the trigonometric identity now. The identity that we are going to use now is this. If you have, say, cos of c multiplied by cos of d, this is equal to half of cos of c plus d plus cos of c minus d. This is the part. Now what I'm going to do, I'm going to compare the c with the 2x, d with x, right? So that's my substitution now. So what I'm going to do here is, this is equal to substitute. So instead of cos c cos d, I can write there is a half into, this is cos c plus d, 2x plus x is 3x, okay, plus, now you see cos c minus d, c minus d is 2x minus x is simply x, cos of x. So whole numerator is, numerator which was a product in the previous case is actually converted into a sum now. I don't have a problem with this. This is good for me. Okay, so I'll show you how. Let's proceed. So that's divided by the denominator, which is the d square plus 9 as it is. Okay, this is d square plus 9. Mistake. 1 second. Yeah, this is d square plus 9. Okay, so this is equal to, now I split this term because I want to make a substitution. So half I'll take out, half cos 3x divided by d square plus 9. This is my first term, plus another half I multiply inside. This is cos of x divided by d square plus 9. Why we splitted the terms? Because I have a substitution, like if you have a cos ax by something, I can have a substitution. This is another cos ax and another denominator. So now I have a solution. Previously that was a product and we didn't had any specifications about which one to be substituted. Which one is A? I don't know. But now I am very sure that this is the A I am going to substitute. So what A I am going to substitute? Right? For the first term, I am going to replace the d square by, right, minus of a square, and the a is equal to 3 here. Okay, if you see a is equal to how much? A is 3. So 3 square is 9. I am going to replace it as minus 9. Similarly, the second part, replace the d square by minus a square, but a is 1 in this case. So a square is minus 1. So see the difference. Our basic fundamental rule remains still same, but I may have to repeat that several times in the same problem. Okay, that's what the variety I wanted to show. That's why I took this problem. Okay, remaining steps are same. Half, I have cos of 3x divided by d square is minus 9. So see, I'm showing you a different thing here. This is minus 9 plus 9. So what is this? Minus 9 plus 9 is actually 0. I should not have that, right? So you see, this step goes one step ahead now, right? It actually takes care of the denominator being 0, right? So we have to take care of that. So what I do, I will not proceed. I'll just substitute this, but I will not write 0 there because it should not be equal to 0, right? Plus, so minus 9 plus 9, I don't write 0, okay? So hold on to that. Plus half into, this is cos x divided by, here no problem, minus 1 plus 9 is a 8, correct? Minus 1 plus 9 is 8. So that is, I can write this part as half into 8. So the second part I can write, but first part I have a 0 here. So because this tends to 0, what I should do, remember, keep the terms as it is, half, multiply that by x, keep the numerator as it is, that is, sorry, screen, we had done till here. Now, so I'm applying the rule that it says that keep the constant as it is, there is a half, multiply the term by x, keep the numerator as it is, 3x, denominator you need to differentiate. Which one you are going to differentiate? Not the minus 9 and this term what you had, this you differentiate and write over here. Okay, that's what is coming here, differentiate, right? I write f dash of d should come over there, d square is there. So when you differentiate d square with respect to d, this is 2d. Sorry, I'll change the color back to black. Okay, so that means this is 2 times d. The 9 has a differentiation which is 0, so I don't have that. Okay, this is the term, plus I have cos x, cos x divided by 2 into 8, which is 16. So this second term is fine for us. We don't have to deal with this anymore. That's the final part which is going to come. But only this first part I need to see what I can do. Okay, all right. Now let's go ahead. This is equal to, I'll write the half x, I'll keep as it is. Okay, now the cos 3x divided by 2d. Okay, I'll actually do one more thing. I'll multiply the 2 with the 2 and I'll write a 4 over there. That will be very easy for us. Okay, so this is x by 4, I'll take it out. Okay, and then I write the cos 3x divided by d. Okay, now this means in order to cancel this d, I'll multiply by d and I'll divide by d. Okay, the same thing, right? Because I need a d square in the denominator somehow. Without that, I cannot do this. So this is plus, the second part is cos x by 16. That will remain as it is. Okay, no change with that. So this is equal to, see, the first part is as it is, x by 4 you are going to keep it as. So d into cos 3x, differentiation of cos 3x is minus sine 3x into 3 divided by d square. Denominator is d square. Second term as it is, this is cos x divided by 16. All right. So I'll simplify this. Now this is, there is a 3 and minus out. So this is minus 3x by 4 minus 3x by 4 into, so this is not minus, sorry, minus I took out. So this is just sine 3x by, so what is the term you are going to do here? D square should be replaced by minus 9, correct? So this is minus 9. Replace the d square by minus of a square. So that's the term plus cos x by 16. Okay, now, so this is equal to, let's simplify, 3 cancels with this as 3, minus minus cancels. So this term becomes x into sine of 3x divided by 4 into 3, that is 12, plus cos x by 16. So this is the x sine 3x by this plus cos x by 16. Yes, so this is the yp. Okay, so we got a yp now. So therefore, the y is equal to final answer yc plus yp. So yc we already had collected it as c1 cos 3x plus c2 sine 3x plus the yp part, that is x sine 3x whole divided by 12 plus the cos x by 16 is the final answer. Okay, so that's the final answer which we get for this particular problem. Okay, now I'll give you one homework problem to solve. You can practice and let me know if you have any doubt in the homework problem in the upcoming classes. All right, so the first problem is homework. This is okay, y triple dash minus y is equal to 3 times cos of 2x. Say that's a problem number 1. Then let me give another one, so that should be y double dash plus 3y dash plus 2y is equal to 4 cos square x. All right, and let me give one more question, that is d cube y by dx cube plus y should be equal to 65 times cos 2x plus 1.